In this video, we're going to explore hypothesis testing for the mean of small samples. Now, just like how we did testing of the z-score, when we're dealing with small samples, we're going to use the t-distribution. But the steps are going to be pretty much the same. Just to remember, the t-distribution, the mean, or the number of samples that we have is less than 30, but we know the underlying distribution is normal. Whenever we're first going to find the rejection regions and the critical values. So to find those critical values, we need to know the level of significance, which is our alpha, and our degrees of freedom, which is n-1. Then we have to determine whether we're doing the left, the right, or the two-tailed test. We use our alternative hypothesis to help us put that together. Depending on your test, you're going to use one of these three formulas using Excel 2010. The big thing to pay attention to is that when you do the two-tailed, the positive value is found using the test, so then the negative value is just the same value except negative. Let's look at two examples. Say that I want to look at a left-tailed test with a rejection region and an alpha of 0.03 and sample size of 16. I'll plug that into the left-tailed test using Excel, and I get negative 2.034. And since it's a left-tailed test, I know that I would draw my vertical line at negative 2.034 and shade to the left. That would be where I reject the null hypothesis. Say I want to do a two-tailed test at 0.1. This time I'd use the tinv.2t and I just use the alpha and the n-1. I get 1.753. Now I know then that the negative is just the negative version, and then I plot the two, and if my value falls in either rejection region, then I would reject the null hypothesis. So the steps are very much similar to how we found it when we were looking at large samples. We want to state our claim, our null and our alternative hypotheses. We want to find that level of significance and the degrees of freedom so that we can put together the critical values in the rejection regions. Then we use the data we're given to put together a t-statistic that we test to see whether or not it falls in the rejection region. If it falls in the rejection region, we reject the hypothesis. If it does not, we fail to reject. And then we interpret our decision based on the context of the claim. So let's look at an example here. Toshiba claims to have a battery life of at least 8 hours. And so Consumer Report tests 20 laptops, finds the average battery life was 7.8 hours with a standard deviation of 3/4 of an hour. You want to know, is there enough evidence at the 0.05 level? So we start by stating our claim and our two hypotheses. So in this case, the claim is based in the null hypothesis. The alternative tells me that this is going to be a left-tailed test, and I'm just going to plug in directly into the formula and get that my critical value is negative 1.729, and I would shade to the left. Now I'm going to create the t-statistic based on my information that Consumer Report found. They found the mean of 7.8. I'm testing against a mean of 8, my standard deviation, and my sample size. That gives me negative 1.193 for the t-value. Now if I look at my graph, that does not fall in the rejection region, so I would fail to reject the null hypothesis. So what this means is at the 5% level, there is not sufficient evidence to reject Toshiba's claim that their battery life is at least 8 hours. Let's look at another example. Say a local company claims that they're averaging 20 pounds of recycling material a day. You want to test it, so you collect their recycling material for 27 days and find their average is 19 pounds with a standard deviation of 1.75. You want to know, is there enough evidence to support the store's claim? So their claim is an average of 20 pounds per day, so that's going to be an equals and not equals problem, with the claim being on the null. So that's a two-tailed test. So I plug in my information into the two-tailed formula, and I get 2.79, which means that my critical values are going to be positive 2.779 and negative 2.779. Now I'm going to create my statistic based on the average that I found. So I plug in 19 because that was the average we found from our test. 20 is what we're comparing against. 1.75 was our standard deviation, and it was 27 days we were sampling. That creates a t-value of negative 2.97. And if I plot that, that would actually fall in my lower rejection region. That means I will reject my null hypothesis. So in this case, at the 1% level of significance, there's sufficient evidence to reject the company's claim that they're recycling at least 20 pounds a day.